Hello, Chemistry 20 students. Today I just want to talk a little bit to you about the law of combining volumes. In your workbook, it starts on page 22. So, simply stated, the law of combining volumes says that when measured at the same temperature and pressure, that volumes of gaseous, reactants, and products, and again, notice it said gaseous, are in simple whole number ratios. Basically, all that means is that when we balance an equation, the coefficient numbers that we use to balance it are whole numbers 1, 3, and 2. So to explain the law of combining volumes, I like to go back to a family favorite recipe for something that we call in our family scotcheroos. In order to make this dessert, you combine 1 cup of sugar with 1 cup of corn syrup, 1 cup of peanut butter, and 6 cups of Rice Krispie. When you mix those ingredients together, you end up with 1 pan of squares. The problem is sometimes we have large family gatherings and 1 pan of squares just doesn't cut it. We need more than that. So let's say that instead of 1 pan of squares, we needed 6 pans of squares. If I knew that, I could use the whole number ratio to figure out how much of each of the 4 ingredients I need to put in. If I multiplied the recipe by 6, every ingredient that goes into that recipe also has to be multiplied by 6. So 6 times 6, I would need 36 cups of Rice Krispies, and 1 times 6, I would need 6 cups of sugar, 6 cups of corn syrup, and 6 cups of peanut butter. And if I combine those whole number ratios, I would end up with 6 pans of squares. So in a nutshell, that's really what the law of combining volumes is. The difference is instead of dealing with solids, we are dealing with gaseous, reactants, and products. In this simple composition reaction, when we combine when we combine nitrogen and hydrogen, we can produce a product known as ammonia. And notice that each of these are gases. Now, in a chemical reaction, all of the reactants and products don't have to be gases to use the law of combining volumes, but the law only applies to those that are in the gas state. In our case, they're all in the gas state, so we can make this work. When you're using balanced chemical equations, these balancing numbers, called the coefficient numbers, always mean moles. So always 1 mole reacts with 3 moles to make 2 moles. And that may sound weird. How do you add 4 to get 2? But if we remember the law of conservation of mass, if you calculate the mass that went in and the mass that went out, it would be the same. The interesting thing that Avogadro and Gay-Lussac determined is that these balancing numbers, if they're gases, not only mean moles, but they can also mean volumes. So I could say 1 liter of nitrogen reacts with 3 liters of hydrogen to make 2 liters of ammonia. And again, you might say, how do you put 4 liters in and only get 2 out? Well, we know from our studies in chemistry that nitrogen is a diatomic molecule. Hydrogen is also diatomic. And if we look at ammonia, the compound that we produce when we put them together, we had 2 nitrogen atoms that went in, and we had 2 nitrogen atoms that came out. We had 6 hydrogen atoms that went in, and 1, 2, 3, 4, 5, 6 hydrogen atoms that came out. Hopefully that helps you understand how this works, even though when you first look at it, you think, how is that possible? I will put a link on on Google Classroom that will explain this if you want to, if that's really confusing you. So again, just like our recipe, we don't always want to produce just 2 liters of ammonia. Maybe we need a different amount of ammonia. And we can use the same concept that I used up here to calculate those values. So I'm going to do question number 1 on page 23 in your workbook as my example. So the question says that in a simple composition reaction, you produce ammonia. And the question states, we want to produce 3.4 liters of ammonia, not 2 liters, but 3.4 liters. And it asks us how much of this would we need and how much of that would we need. So we need to do 2 different calculations here. So this is the way to proceed with these. We'll start off with nitrogens just because it's the first one listed in my formula. So the question asks, how much of each of these reactants do I need in order to produce that 3.4 liters of ammonia? So in our chemical equation that we're doing right now, I'm just going to move this up so I can do both of them here. It's going to require us to do 2 calculations because the question says how many liters of each of the reactants do we need to produce this 3.4 liters of ammonia. So in my calculation here, or in chemistry, we refer to this as the given. It's the value that's given to me in the problem. In our case, we're going to do this one first. So this is my required chemical. That's what I'm required to figure out. So we always start with the given value. So I say, I want to calculate the volume of nitrogen needed. That is equal to the given amount, 3.4 liters. And I'm going to put here what the chemical is, 3.4 liters of ammonia. And then I'm going to multiply it by the ratio between ammonia and nitrogen. Now, if you remember from our previous studies, if I start with liters of ammonia, then that will have to go on the bottom so that I can cancel it. So I go to my balanced equation. Remember, these values always mean moles, but in our case, because they're gases, I can also refer to them as volumes. 2 liters. So 2 liters of ammonia for every 1 liter of nitrogen. This allows me to cancel my liters of ammonia and be left with liters of nitrogen, which is what I'm trying to figure out right now. So I simply go 3.4 times 1 divided by 2, which gives me 1.7 liters of nitrogen. So that's my first question. The second one says we need to also figure out hydrogens. We've already done this one. We need to figure out hydrogen. What did I do here? There, let's do this again. Volume of hydrogen. And that's going to be equal to the given amount of 3.4 liters, just like in the first one. Again, 3.4 liters of ammonia, and I'm going to multiply it by, in this case, this is my required, right? I already did this. Now I'm figuring this one. I started with ammonia, so once again, ammonia's balancing number goes on the bottom. And my hydrogen, which I'm trying to figure out, is my required, will go on the top, and I have 3 liters of hydrogen. So all I do is plug that in my calculator, 3.4 times 3, $10.2, And then I'm going to divide that by 2. Let's try that again. And that gives me 5.1 liters of hydrogen. And that is my calculation to determine both answers that were required in the question. Again, hopefully that helps. I will put the link up for the video that explains this concept maybe a little bit better. Also, the Tyler DeWitt videos are very good with Avogadro's theory and the law of combining volumes.